and kind of run through long division first and then something that we call synthetic division. Okay, so first of all, before I do this problem right here, I want to just remind you of how you would do something like with arithmetic. Okay, let's say, for instance, you were doing 20 divided by 8. Okay, right? And sometimes if a student's an international student, they never learned how to divide this way. And when I do the algebraic process, I'm going to do it this way. So when you do long division, and I always like to do this before I do the algebra, so just to refresh your memory, because sometimes students haven't done a long division problem in years. So you divide, you multiply, you subtract, and then you bring down the next number, okay? Like this. So let me do this real quick, and that'll help you understand the algebra. Okay, so the first thing that you do on this is you would do 20 divided by 8, which is 2. Then you do 2 times 8, which is 16. Then you subtract, you get a 4. Then you bring down the next number as a 5. Then you divide again, so that would go in what, 5 times? Okay, then you multiply. 5 times 8 is 40. Subtract, you have a remainder of 5, okay? Now the way you learn how to write this answer, when you learn how to do this in elementary school, is you do 25 and you do 5/8, right? Okay, so when I do the algebra, I'm going to do this exactly the same way. Okay, exactly the same way. All right, so we're going to go ahead and get this put together, and you want to do this like this. Okay, so write this down, please. Please. Okay, we got x squared plus 4x minus 45. Then we have x plus 9, like that. Okay, so what we're going to do, and as I'm teaching this, one thing that will be helpful is to kind of, write the steps. The division step, what you're doing is you're doing this number divided by this number. Okay, what is the result of x squared divided by x? That's x. Okay, so that records there. It doesn't matter where you put it. I'm going to put it there. It doesn't make any difference. So that's step 1. Step 2, you want to go x times x plus 9. Okay, like that. So you're multiplying. That's the multiplication step. Do that in your head. That is x to the second plus 9x, and then record it here. So that's plus x to the second plus 9x, like that. Okay. Step 3 is to subtract. So there's always division, multiplication, subtraction. Now here's the way I do this. You can do this in your head. You're doing x squared minus x squared cancels, right? Be careful here. This is 4 minus 9. So what is that? Negative 5. Okay, so it's got to go like that. Okay, you are subtracting. This is the most common place students slip up. So one of the things I tell students to do is just change the signs, because when you subtract, you change the signs and add anyway. Okay, and then the next step would be to bring down the next number. Okay, so we have minus 45, like that, and then we start all over again. Okay, you guys follow what I did or not? Only way you're going to know is if you do problems, obviously, so you got to go through it like that.
I'm so lost on why we make it minus.
The minus, okay? So what I did on this, and you can do this in your head, what I'm doing is the third step is this minus this is nothing. That cancels. Then I'm doing 4 subtract 9, which is a negative number, right? Mm-hmm. Okay? And see, like if that was a minus 9, then you would go 4 minus negative. You're always subtracting, whatever that number is. One thing that does help students sometimes is just change those signs, change that to minus, and then just combine. Because it's the same thing. That's what subtraction is. Okay? All right, now what we do is we start this all over again. Okay? So what we do now is we take this number and we divide by that number. And you can do all this in your head. You don't have to write the steps, but when I'm teaching this, I want to make sure that you see what I'm doing. So I do this divided by that. What is that? Negative 5, right? The x's cancel out. So we have minus 5 there. Now it's the same stuff. So we go step 2. We're going to go negative 5 times x plus 9. And again, you do that in your head. Negative 5 times x is negative 5x. Negative 5 times 9 is negative 45, like that. Okay, now here's the subtraction thing. So what are you really doing? You're doing negative minus a minus. When you do minus a minus, what do you really do? You do plus, okay? And same thing here. Negative 45 minus negative That's going to give you 0, isn't it? Okay. If you don't like doing it that way in your head, then do it this way and it'll help you. Just change that to plus, change that to plus. That'll cancel, that goes to 0. So what you'd end up having is the quotient would be this answer, which is x minus 5. Okay, then the remainder is going to be 0. Now we're going to do what we call synthetic division here in a minute, which is a little simpler than this, but you have to know how to do both. If you're going to higher math, you got to know how to do both. Okay, it's important. Okay, any questions about that? Okay. All right, so let's do one more of those and run through one more like this, then we'll get into the synthetic and I'll show you what we're doing with this then. Okay, so we have 20x to the third, then we have minus 7x squared, minus 2x, plus 11, then we're going to divide by negative 4x plus 3 like that. Now this problem right here has one more round through it then, okay? So what we do is we start this way. You start with this division, okay, and you want to just do this mostly in your head. So 20x to the third divided by negative 4x. What is that? 5x. Negative 5x squared. Make sure you're careful about the negative. So you record that. I usually record it above the power, but it doesn't make any difference. Okay, step 2, we're going to multiply. Okay, you don't have to write down these steps at the side here. I'm just trying to show you what I'm doing. So negative 5x squared times negative 4x plus 3. So I do this in my head. Negative 5x squared times negative 4x is positive 20x to the third. See how it matched? It always will. If it doesn't, you've messed up. Okay, so it's kind of like self-checking. Same thing here. Negative 5x squared times this is negative 15x to the second, like that. Okay, now that doesn't match. Okay, what's the third step? Subtract. That's where students mess up more than anything else. I like to just teach students, change the sign and add, because that's what subtraction is. So that's going to cancel out. Negative 7 plus 15 is 8x to the second. Then what? Bring down the next number. Okay, then you're ready for the next loop, see? Okay, so we're going to keep doing that until we get everything taken care of. So now what we do is we repeat this. We take this number divided by this number and we do this then. So I'm back to the beginning. So I do, whoops, I just highlighted the wrong number. This, we want to do this divided by that. So that's the next step. Okay, so we're going to do 8x squared divided by negative 4x. So that is negative 4x. Okay, so I record that right there. Okay.
2x, isn't it?
What's that? Oh,
2x.
yeah, 2. Gosh, come on. All right, thank you. So that's 2. All right, okay. Then we multiply. You know, I would have caught my mistake because it's going to check. So here's what happens. Negative 2 times negative 4 is positive 8x to the second. Negative 2x times 3 is negative 6x. Okay, then I subtract. So I change signs and add. That's just the way I do that. So you're really doing negative 2 plus 6. So that's 4x. Then you bring down the 11 like that, and then you've got one more loop to go through the problem. And notice the answer, the exponents are going down. That's what will happen. And then the next thing you do is you do this divided by this. Okay, so now we do 4x divided by negative 4x. That's equal to negative 1. Okay, so we do that. Then we multiply, and then we'll be done. So we do negative 1 times negative 4x is positive 4x, which matches. Negative 1 times positive 3 is negative 3. Okay, then what we do is subtract. So again, I'm going to change these signs. Add that up, so I have 11 plus 3, because I'm doing minus minus. So that gives me a remainder of 14. Okay, so the quotient is this number, or that expression. So you would have this. Okay, that's how that goes. Okay, and you need to know how to do that. There's a because there's going to be things in the future in the class you have to do this on. Okay, what do you think? You guys follow what I'm doing? Okay. Okay, so it's just like arithmetic, except you follow the same exact strategy. Okay, next thing I'm going to show you is how to do synthetic division, which is usually a lot easier for students to learn. And synthetic division doesn't always work. It works in a certain case. So really it only works if you're dividing by these two things. So we're going to look at problems where you're dividing by just like x minus something or x plus something. So like on this problem I'm going to do here in a minute, that's the thing that you want to do synthetic division on, okay? So what you want to do, and when you set this up, it turns out that this is a lot less work than what I just did. What you want to do is you want to put the numerator under the division bar, but all you do is you just put the coefficients. And you got to make sure everything's accounted for. See, this is a fifth power, so you got to have a fifth, fourth, third, second, first, and a constant. Everything's got to be there. So what we're going to do is just put 1, leave a little gap, have a 7, a 12, another 12, a 13, and a 16 like that. Okay? Now, here's the next thing you do, and you got to pay attention to this and make sure you do this right. Okay? What's the solution to this equation? Set that equal to 0. What do you get? You get x is -5. So you have to put -5 there. Okay? Because the structure of this is x minus -5. You're always dividing by x minus something. So if you're dividing by x plus something, it's really minus minus, okay? So if you haven't ever done this or haven't done this in a long time, watch carefully how I do this. It's a very simple process. So the first thing you always do is you just bring that 1 down like that. Always start that way. Now what I'm going to do is I'm going to multiply. I'm going to do this kind of slow this time, then I'll speed up. -5 times 1 is -5, so record it there. Okay? Then add the column. So 7 added to -5 is +2. Okay? Now we go back and we do this over again. Multiply. -5 times 2 is -10. And then you always add the column. So 12 added to -10 is 2. Okay? Now just repeat yourself. 2 times -5 is -10. Add the column. That's 2. Multiply. 2 times -5, -10. Add the column. That's 3. 3 times -5 is -15. Add the column, you get a 1. Okay? You guys see what I did? Okay, it's just really bring down the first number, multiply, add, multiply, add, multiply, add, over and over again until you get a remainder. So this thing right here is the remainder. So you have a remainder of 1. And then it goes like this, okay? This number right here is a constant term. This would be 2x. This would be 2x to the second. This would be 2x to the third. And then this would be 1x to the fourth. So what happens if you kind of read from right to left, you have a remainder, a constant, and then the exponents get bigger. So the quotient is this. This right here is your quotient. So you would just say x to the fourth plus 2x to the third, plus 2x to the second, plus 2x, and then the constant is +3. Okay? Now this is a quicker, easier way to do long division, but it only works if you have like divide by x plus 5, x minus 5. That's all. The only time it's going to work for you. Okay? All right, any questions about that? Yeah, go ahead.
So your basic, is that always consistent? The last number is the remainder?
Yes. Yep. Yeah, it's remainder, constant, then the x's get bigger. Or you can think of it this way if you want to. If you divide x to the fifth by x, you get x to the fourth, right? So that means this is going to be 4, 3, 2, 1, constant, then remainder. You can do it that way if you want to. Okay, do you have something? Are you okay?
No, I answered it in my head.
You got it figured out?
Yeah.
Okay, very good. Okay, let's do another one like this. And we're going to do this a bunch because then we're going to start learning what we do with this. So with this one, there's one little thing that you got to do differently. So if you have x to the third minus 3, you need to have, for each power, you've got to have a location. Okay, so what happens in this is we have the constant -3, and we have the 1x to the third, but you don't have a second power, and you don't have a first power. So you've got to put in missing places. You have to. It won't make any sense if you don't. So I go 1x to the third, 0x to the second, 0x, minus 3, like that. Okay? Now, look at what you're dividing by. You have x minus 1. I just recommend to keep you from forgetting this, Solve that equation. So that solution is what? 1. So put a 1 there. Okay, like that. Now you're ready and set up and you're ready to go. Okay? All right, so let's do this. We'll do this a little quicker this time. Bring down the first number. 1 times 1 is 1. Add the column. 1 times 1 is 1. Add the column. 1 times 1 is 1. So we'd have -2. Okay? Now again, like I showed you, this is the remainder. Okay, so -2 is the remainder you're going to have. Okay, and then do it like this. See, the third power is going to go down to 1x to the second plus 1x plus 1 and then a remainder like that. Okay, so that means the quotient would be x squared plus x plus 1, and you would have a remainder of -2. Okay? All right, does everybody follow that okay? Okay, all right. Okay, so we're going to do that and kind of apply that in a lot of things, but I want to start by showing you the procedure to do that before we do any applications. So I'm going to do one more of these. This one's just got a fraction, and you want to make sure you can handle fraction arithmetic. Okay, so with this one, we have missing terms. So you have 3x to the fourth. You don't have an x to the third, so what do you put? 0. You do have an x to the second, so put a 4. You don't have an x to the first, so you put a 0. And you do have a constant. See, this is going 4, 3, 2, 1, constant. Everything's got to be accounted for. Okay, tell me what goes here. Is it 1/2 or -1/2? 1/2. Okay, solve the equation. X minus half equals 0 to keep you from forgetting that. So that's a half like this. Okay? So again, we just want to deal with the half. It's easy to work with a half. That's not a big deal. So bring down the 3. So you do that. Now if you multiply 3 times 1/2, okay, just multiply straight across and get 3 halves. Don't do decimals, just do fractions. Okay, you don't want decimals because sometimes they don't have a decimal that ends. So we want to do 3 halves like that. Okay, now add, that's 3 halves. Multiply, you can do that in your head. I'm going to kind of do that the side since it's fractions. So that's going to be 3/4. Like that, okay? I'm going to erase some of this scribbling here as I go. Okay, the next thing we do is 4 over 1 plus 3 over 4. Well, you got to get a common denominator. Okay, so you can multiply by 4 over 4 to get 16/4 plus 3/4. So that's going to give you 19/4 like that. Well, hold on, don't put it there. Don't put it there. Okay, put it here. So that's 19/4, okay? Right, now we multiply, so I'm doing 1/2 times 19 over 4, that is 19 over 8, add the column, so that's 19 over 8, multiply a half times 19 over 8, that's going to be 19 over 16, okay? And then finally we got to do -1 plus 19 over 16, so you can just write the -1 as -16 over 16, plus 19 over 16. So that gives you 3/16. Okay, you got to learn how to deal with fractions and make sure you get over any problems you have with that. So the remainder's 3/16. Okay, what would be the highest power in your result? Third power. Okay, the fourth goes down, so you're going to have 3x to the third plus 3 halves x to the second plus 19 over 4x. This is a constant. Okay, then you'd have your remainder. So it goes like that, all right? Okay, any questions? That's harder because of the arithmetic, but you need to be able to handle that okay, regardless of what the numbers are, okay? All right, so the next thing I'm going to do is I'm going to show you, we're going to kind of build up to a certain thing. The reason we're learning synthetic division, because you can do an analysis of functions and their zeros real easily with this. So the first thing I want to talk about is what's called the remainder theorem, and go through this just a little bit here to start with. Okay, yeah, go ahead.
On the last one, where'd you get those zeros from?
There was missing terms. Okay, so notice this is a fourth power. There's not a third power, so you have to put a 0. There's an x to the second, you put a 4, there's not an x. So you want to think of this as 3x to the fourth plus 0x to the third plus 4x to the second. You see what I mean? everything's got to be accounted for. You got to have a placeholder for everything if it's not there, right? So on the remainder theorem, here's what I want to do on this problem, okay? So let's go ahead. The first thing I want you to do, we're not going to do a graph on this. I'm going to have you do this instead. So we're just going to find f of 1/2. And what we know is that just means take your function, everywhere you see an x, put in a half, and then work out the details. Okay, now we're just going to go ahead and do it this way. Then I'm going to show you what the remainder theorem is. You'll understand it a little better this way, I think. And we'll do graphing a little later. Okay, so what we'll have is -8 over 1. If you take a half times a half times a half, you get an eighth. Then you'd have 16 over 1. If you take a half times a half, that's a fourth. And then I'm going to do 8 over 1 times 1/2 like that. Okay, and the arithmetic on this is real simple. So if you multiply that straight across, that's -8 over 8. I'm going to do it this way. Multiply that across, that's 16 over 4. If you multiply that across, that's -8 over 2. So what you're going to get is -1 plus 4 minus 4. So you get f of 1/2 is equal to -1. Okay? Now that's evaluating a function. I wanted to throw in the fraction on there because students a lot of times need to work on that. Okay? Now that's not the remainder theorem. What the remainder theorem is this. And I'm just going to use this and demonstrate this. What we're going to do is we're going to do synthetic division on this -8x to the third plus 16x squared minus 8x. Now I'm going to write that down so that you see something. So we're going to make our division bar. And you got to be careful about this. -8 goes there, 16 goes there, -8 goes there. Is anything missing?
Constant.
Yeah, the constant's missing. Good. See, that's +0. And you absolutely have to have that in there. It's important. Okay, now what you do on this is, I didn't give you like x minus something or x plus something. You just divide by whatever I'm interested in. Okay, so we're going to do synthetic division, and I'll show you what happens. So let's go ahead and synthetically divide this. This will be fairly easy to do. So you bring down the first number. If you take half of -8, that's -4. Add the column, that's 12. Half of 12 is 6. That adds to -2. Half of -2 is -1. So your remainder is -1. Do you notice anything? Same answer. It always works. That's what the remainder theorem is. So the remainder theorem says that if you synthetically divide that polynomial by a number, whatever the remainder is the same as the function value. So what you have is a remainder of -1. That means that f of 1/2 is also -1. Okay, that's the remainder theorem. Now, if you're on a test and I say evaluate f of 1/2 by the remainder theorem, you can't do this way. That's not the remainder theorem. If I say do the remainder theorem, you do it this way. Okay, so you want to pay attention to that. Okay, the remainder theorem means you are dividing. I see students on tests do it that way. That was only to show you what the remainder theorem was. Okay, all right, everybody okay? Okay, now I'm going to do something now with the graph. We're going to move on to the next page here. And I did a bunch of graphs on these things that I want you to just look at as we go through this. Okay, so future test question. Here's a polynomial. Find f of -2 by the remainder theorem. What you're going to do is this. Okay, we're going to go through and synthetically divide this. So everything is accounted for. You have a 1, -4, a 3, a 5, and then you just use -2 like that. Okay? And you can do this real quick if you've got this down. You bring the 1 down. -2 times 1 is -2. The column adds up to -6. Multiply, you get 12. Add the column, that's 15. Multiply, that's -30. Add the column, that's -25. Okay, so what's the remainder? -25. So therefore, what is f of -2? -25. Now, I'm not going to do anything on the calculator, but I want to just show you. You don't need to draw a graph on here. You can if you want to. But if you put this polynomial in your calculator, this is what this polynomial would look like. And what I've done on this is that this is just going negative 50 to 50 like this, what we just did is f of negative 2. So here's negative 2. If you went to the function value on that, that function value is negative 25. Okay, that's what will happen. So basically, anytime you get a remainder, that will tell you what the function value is. Okay, does that make sense? Okay, all right, so it's a quick way. A lot of times it's easier to do the remainder theorem than it is to just plug in the negative 2 and calculate. Not always, but sometimes it is, because you can do it real fast. Okay, everybody okay with that? Okay, so if I am asking for remainder theorem, you divide. Okay, you got to do synthetic division and look for the remainder. Then you've got your function value. Okay. Okay, next thing I want to do is factor theorem. This is kind of leading up to a certain point of what we're going to learn how to do here today. So what a factor theorem is it basically says this, okay? Like if you were going to factor this polynomial, well, you might have a little bit of trouble factoring that. It's got 4 terms. You might be able to do it, you may not. So what we're interested in, the question on this is that a factor of that polynomial? So in other words, if you factored what I highlighted in yellow, would x minus 1 be one of the factors? Okay, so it turns out what you do on this is you do synthetic division. Okay, so we're going to set up synthetic division again. So we're going to have x the third, which is 1. We have negative 10, 27, and then we have negative 18. Okay, now again, we did this a minute ago, so x minus 1 equals 0. That means you want to divide by x equals 1. Okay, so here's what happens when you do the factor theorem. If this remainder ends up being 0, then it's a factor. Okay, because then it would end up being the function value. If the function value is 0, then that means you're right on the x-axis. It's like an x-intercept. That's what it means in this particular problem. So what we do is we bring down the 1, multiply, that's negative 9. Multiply 1 times negative 9, that's negative 9. Add the column, that's 18. 1 times 18 is 18. So you have a remainder of 0. So what that really means is it means that you have a factor. So that would be yes. And that's because that remainder is equal to 0. Okay? And here's why. Let me show you what this means, because you want to understand the why part of this. This part right here is really represented by x minus 1. This part right here is really representing x squared minus 9x plus 18. That's how you factor that polynomial, is by doing that. So that's the factoring of that. And because that remainder is 0, that's why it's a factor. Okay? When you look at the graph on this, I went ahead just before class and put some graphs on a lot of these. What would happen is if we divided by x equals 1, notice on my graph that when x was equal to 1, y was equal to 0. Okay, that's because the remainder theorem says that the y value at 1 is going to be the remainder. Okay, does that make any sense? Okay, tell me. Okay. Okay, so what you're doing again on the factor theorem, see if it's 0 remainder. If it is, you know you got a factor and you've got the polynomial factor. That's how you factor it actually. Okay, that's the idea. Okay. Okay, let's do one more like this, and then let's kind of build it from here then. Okay. Okay, so let's see. Everything's accounted for. You have 1, then you have negative 10, 14, and 80. Is anything missing? Any zeros needed?
No.
Nah, okay. Okay, you have x plus 5. What are you going to use? Are you going to use 5 or negative 5? Negative 5. Okay, so we got x equals negative 5 like that. Okay. Now let's go ahead and start, and let's see what we come up with. So once you do this, you can do this pretty quick if the numbers are relatively small. So I bring down the 1, multiply, that's negative 5, add, that's negative 15, multiply, that's 75, add, that's 89. I'm not even going to bother. I don't know what 89 times negative 5 is, but it's not going to be 80, right? You see what I mean? There's no need to even bother. This thing right here is not going to be 0. Okay, so if you went through and did that, you would not get 0. So you don't have to do it. Once you get to a point where you see that that remainder is not equal to 0, then you're done. Okay, so it's not a factor. okay? What would happen on this particular problem is if you graphed this, and I didn't really, if you went to 1, 2, 3, 4, -5, your function value would be way down there. Did anybody do that with their calculator? I saw some of you pressing buttons on your calculator. Anybody get the remainder?
-365.
-365. I figured somebody did. So actually, what you would have is a point -5, -365. The point of the problem, though, is it's not a factor. Okay? So that's the idea. All right, any questions? Okay, all right. So if I want you to do the factor theorem on an exam, what do? Synthetically divide and look at the remainder, right? You're just trying to see if the remainder is 0 or not, okay? Hey, if you study and know how to do it, know how to do synthetic division, there's absolutely nothing to it, okay? Now, what I want to do with this one, this is just one other thing, then we'll go to the second part of this 5.2, is we're going to find k so that we have a factor. Okay, we're going to synthetically divide on this one also. So our polynomial, I'll highlight the polynomial in yellow. There's no missing terms, so we have 1, 8, 14, and then go ahead and put the k. The k is a constant, but we're going to find what it is so that it makes this a factor. Okay, what do I use, 5 or -5? -5, good. Make sure you don't mess up on that. Okay, now we're just going to run through synthetic division again. So bring down the 1, multiply, that's -5. Add, that's 3. Multiply, that's -15. Add, that's -1. Multiply, that's 5. So what's k plus 5? Well, it's just k plus 5, right? Okay, so that is your remainder right there, is k plus 5. Okay, but here's what the deal is. You want this to be 0 in order for that to be a factor. So what would k have to be in order to make that a factor? -5, exactly. K has to be -5. It can't be anything else. Okay, that's the idea. That's just a little twist on the problem, just to see if you're thinking. Okay? Okay, any questions?
So that would be a factor. So if
if you change that k to -5,
then that would just
then x plus 5 would be it. Yeah, and it would be a 0 anyway, wouldn't it? Okay, all right. Okay, so let me load up this second part right here. So this is what we're trying to kind of lead to. You got to spend a little bit of time on synthetic division before you get to a point where you can do a little bit of some applications with that. So the first thing I want to show you is there's a couple of things we want to look at. A 0 of a polynomial, that's a value of x that causes the function to be 0. Okay? If it's a real 0, now we haven't talked about complex numbers yet. We'll do that after spring break. But if it's a real 0, then that means it's an x-intercept. And we've done that today. We had those things already factored. We found the zeros, they were x-intercepts. But that's only if they're real. If they're complex, it's different. So the first thing we want to learn how to do is find potential rational zeros. I like to go over this, although in the modern world, it's probably not quite as important as it was when I took college algebra, because we didn't have graphing calculators when I took college algebra. So when we found zeros, we had to find the list and synthetically divide until we found the one that worked, and it took forever. So what I do, I kind of simplify that a little bit in the modern world, and I'll show you as we go through this. So first of all, when you find a possible rational zero, P is going to be all of the factors of 24. And this is like backwards is the way this is. Q is all of the factors of the leading coefficient. So what you want to do on this, I like you to do this just kind of as kind of a good exercise. All I have you do on an exam is just list the possibilities out. Then I'll kind of explain here in a minute how I can bypass one part of this. Okay, so P. If you're going to do all of the factors of 24, I just recommend you do it like this. Do it in a logical way. 1 and 24 are factors. 1 times 24 is 24. Okay, 2 goes into 24 12 times. That's a factor. 3 does too. 3 times 8 is 24. Okay, and then 4 times 6, and that's it. Okay, and the only thing you got to try is the number between 4 and 6 is 5, and 5 doesn't go into 24. But the other thing you have to do is you have to put a plus or minus by every one of these things. Okay, because you can also have negative factors like that. Okay, so that would be all of the possible values of P. Okay, now Q would just be all of the factors of the leading coefficient. Well, that's a 1. The only factor of 1 is 1, so it's either 1 and minus 1 like that. So you're listing out factors and their possibilities. Now, it turns out if you do the ratio of P over Q, that gives you possible numbers that could be zeros of this polynomial. So what you do is you just take every P over Q. Well, if you did this, you would just have 1 over 1 would be 1. Now, I don't mind if you do it this way. Just put the plus and minus in front of a parenthesis or something. So what I'm going to do is I'm going to do 1 over 1 is 1. Of course, 2 over 1 is 2, and so forth. 3 over 1 is 3, 4, 6, 8, 12, and 24. Okay, so in that case, all I'm doing is I'm just doing a ratio. Every P over Q just gives you the same list, doesn't it? Okay, so that's how that goes. Okay, all right, let's do another one here. Now, if I do this on a test, I don't give you something that has like a million possibilities. Let's kind of put this one together. So P would be 8. What are the factors of 8? 1, 2, 4, and 8, right? Okay, now put the plus or minus. You have plus minus 1, plus minus 2, plus minus 4, plus minus 8. Okay, Q, what are all the factors of 2? 1 and 2. Okay, so you put plus minus 1, plus minus 2. Okay, now when you do P over Q, you do it in a logical way. You're just going to do 1 over 1, 1 over 2, 2 over 1, 2 over 2, 4 over 1, 4 over 2, 8 over 1, 8 over 2. Some of them will repeat themselves, so you don't have to repeat yourself when you do that. So I'm just doing 1 over 1, which is 1, 1 over 2, which is 1/2. Now I go here, 2 over 1 is 2, but if I go 2 over 2, haven't I already used that? Yeah, because I go, like again, I'm going 2 over 1, 2 over 2. I've already used that. You don't need to write it again because that's 1. Okay? Then you go 4 over 1 is 4. Then you go 4 over 2. Well, what's 4 over 2? It's 2. I already got it. You don't need to write it again. Okay, then I do 8 over 1 is 8. And then I do 8 over 2. But again, 8 over 2 would be 4, and I've already used it. So your numbers would be 1, 1/2, 2, 4, and 8. Okay, that's how that goes. Does that make sense? Okay, you're just doing every P over every Q to create that list. Okay? All right, let's do one last one like this, then I'll start putting it all together. Okay? All right, so on P, what is P going to be? 1 and 3. Okay, don't forget your plus or minus. So we got plus minus 1, plus minus 3. What's Q?
Plus minus 1.
Plus minus 1, plus minus 2. Okay, like that. Okay, now we do the ratio. So we do 1 over 1, P over Q. 1 over 1 is 1. I'm doing this in my head. 1 over 2 is 1/2. 3 over 1 is 3. 3 over 2 is 3/2. Okay, that's your list. Nothing repeated, so that's your list. Okay, all right, so you got P, Q, then the ratio. And again, what I'm doing on that, so I'm doing 1 over 1, 1 over 2, 3 over 1, 3 over 2. Just all the possibilities that exist. Okay, that's it. Everybody with me there, okay? Okay. Okay, now this is what we're building up to, is we want to take a polynomial and we want to find its rational zeros. Rational numbers are going to be a certain kind of number. Don't worry about complex numbers. We'll talk about that a little bit later. So what we're going to do on this is we're going to go ahead and do this list one more time. So with this, P is going to be all the factors of 12. So that's going to be 1 and 12, 2 and 6, 3 and 4. Okay? Now, I don't mind if you write it like this. If you just put like a little brace or something and put plus minus, I'm okay with that, okay, because I know what you mean, okay? And then Q is going to be all of the factors of 1, so that's just plus minus 1, okay? So when you do P over Q, what are you going to get? Just this thing, right? That thing, right, because you're doing 1 over 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1, 12 over 1. So that means that your P over Q list is just going to be plus or minus 1, 2, 3, 4, 6, 12, like that. okay? All right, get out your graphing calculator, please, okay? We're going to, see, in the day when I was a college algebra student, which would have been about 1982 or something like that, the teacher said, okay, you need to get some scratch paper out and divide all those numbers until you find a zero. Nobody's going to do that in the modern world. Here's what you want to do, and I'll explain how I test on this too. So put the polynomial in. So you want to do x to the third, and then minus 3x to the second, and then minus 4x, and then plus 12. Like that, just do a standard window. Just go zoom 6, and let me show you what happens on this then, okay? So the graphing calculator will tell you sometimes what all of the zeros are. Sometimes it'll tell you what maybe one of them is just to get you started. Okay, so what I'm going to do, notice on here that some of these things are in this list. So let's just pick one of these. To me, it looks like 3 looks like a 0, okay? The way I test over this is I usually give you the first 0. So I'm going to show you how you find the other 2. Okay, don't just get your calculator out and say, oh, I'm done, problem done. That doesn't really teach you much of anything. So we're going to take the 3 and we're going to synthetically divide it into this polynomial. So we have 1, and let's see, what was that? Minus 3, minus 4, and 12 like this. Okay? Now I want to ask you a question before I even do this. What do you think the remainder is going to be? 0, okay? Right, it's a 0. That's what it means. It made that polynomial be 0. So you're going to know that you're doing the division right. So that's 1. 1 times 3 is 3. That's 0. That's 0. Negative 4. 3 times negative 4 is negative 12. So you get a 0. Okay? So what we have then on this is we basically have this. You're going to end up, this is your remainder, like you would expect. This is your constant. Okay? This would be like 0x, and then that would be 1x to the second. So what you're left with is this. You're left with x to the second minus 4. Okay, that's what you're left with. So what you want to do if you want to find the other 2 zeros, well, you can factor that just set, if you want to, and set it equal to 0. So that factors as x plus 2, x minus 2. So what are the other 2 zeros? What are the solutions of that equation? Negative 2 and 2. Good. Okay, so here's what you end up having on this problem is you have that. So your zeros are, your zeros are 3. We got that from the graphing calculator. Negative 2 and 2. Now sometimes, not always, sometimes these zeros are embedded in the list. Not always though. So you'll have things outside of that too sometimes. Okay, so that's the idea. The way I usually test over this is I don't even have you do the P over Q list. I give you the polynomial and I say 3 is a 0, find the other 2. Okay, without your calculator. Does that make sense? That saves yourself a world of time. So if you're doing this on homework, don't just randomly try things. Just get your calculator out, pick one, and go from there. And it doesn't matter which one you pick. If I would have done a 2, I would have still got the same answer. I still would have got the other 2. All right, does that make sense what it did? Okay. All right, so that's how you use synthetic division to find that. Now I'm going to kind of bypass the P over Q, just kind of put an X on the next one, because I've shown you how to do that. I just like to show you that in case you see that. You probably never see that again, you know, unless you're in really advanced math or something. I know you're not going to see that in calculus or something, but you'll see division in calculus. That certainly comes up quite a bit. Okay, so let's do this. Now what I'm going to do on this one, just to save a little time, is I went ahead and graphed it on my calculator. So if you look at this, it looks to me like negative 3 is a 0. Okay, so let's just give it a try and let's see what happens on that. So again, we're going to do synthetic division. So we're going to do 8, 18, negative 17, and 3. And then we're going to synthetically divide that by negative 3. And we'll know if that's a 0 because the remainder should be 0. Okay? So again, what I'll do is I'll bring down the first number, and you can go ahead and kind of get started on that. So I bring down, multiply, that's 18.